Hi everybody, today we're going to talk about the correlation coefficient R and the coefficient of determination R squared. In the past, we've used scatter plots to determine the strength and direction of correlation. Now we want to add numeric values to our analysis of the data. This will help us to decide when the correlation is perfect positive, highly positive, low positive, not correlated, low negative, high negative, or perfect negative. We use the letter R to stand for our coefficient of correlation. We use R squared to stand for the coefficient of determination. Let's start with a few basic rules. R will always be greater than or equal to -1 and less than or equal to +1. Values that are closer to 1 or -1 have a stronger relationship. Values of R closer to 0 have little to no relationship. And in all cases, correlation does not equal causation. When we look at R squared, we will get a positive value, or in rare cases, we might get R squared is equal to 0. We state R as a decimal, but we're going to state R squared as a percent. R squared expresses the percent of the variation in the dependent variable y that can be explained by the dependent variable x. We'll get more into that as we look at examples. As you can see, the equation for R is quite large and complicated. It would take a long time to use this equation and we could easily make mistakes. So like we've done in the past, we can get rid of the formula and use technology to find R and R squared. Let's start by going to Desmos. In our first example, I have 40 data points. These data points represent the age of the person surveyed and the number of minutes they say they use social media on a daily basis. I'm going to highlight the data, copy it, and hit Ctrl-V to put it into Desmos. There are a few ways to get the value of R inside of Desmos. So let's start by pushing buttons. I'm going to go to the second line, then open up the keypad, go to Functions, scroll down to Statistics, and find CORR. Then you need to tell it where your values are. If you look at the top of our table, our values are x1, y1. So I will type in x1, comma, y1, and I'll close my parenthesis. It gives me a value of -0.974383. To get R squared, there is not a separate button, but we could simply add a parenthesis and then raise to the power 2, which gives us 0.949422754395. If you would like to see both at the same time, there's another way we could do this calculation. So I'm going to clear line 2 and start again. I can go back to finding my line of best fit. Y1 is approximately mx1 plus b. Scrolling down, you'll see that both R squared and R appear under the line of best fit. If I express R squared as a percent, which would be 94.94, I could say 94.94% of the variation in Y can be explained by X. I want to point out a few things about this particular set of data. We said R was -0.9744. That negative is expressed in the graph because we can see our line is decreasing. In fact, if you look at the slope of the line, it's -1.21245. This shows the values are going down from left to right. The value of R is fairly close to -1. You can also see that in the graph because the points tightly fit around our line of best fit. Let's take a look at a second example, and this time let's use Excel. My next example has two columns again. The first column represents the length of a video for an influencer, and the second column represents the number of views in millions. Let's start by making a scatter plot. I'm going to highlight the two columns and make sure I go all the way to the end of the data. Then I will insert a scatter plot. When I look from left to right, I can see the values are going up, so I expect the slope of the line of best fit to be positive. I also expect to get a positive value of R. We will again have multiple ways to come up with the values of R and R squared. One way would be to use the chart itself. Again, at the plus sign, go to the trend line, go over and select More Options, where I ask Excel to show me the equation and R² on the chart. We know that we can click on the equation and make it a little larger. Notice the chart is only giving us R², it is not giving us the value for R. We can find the value for R by hitting equals and hit SQRT for square root, and then put 0.7419, which will take the square root of 0.7419, which would give us a value for R. Another thing that we can do, I'll type R in a cell, and beside it, I'll click in a cell and hit the functions. In the functions, I'm going to go to statistical, and then I'm going to scroll down until I find correlation. This says it returns the correlation coefficient between two data sets, which is exactly what we want. When I hit OK, it's going to ask me for my data. So my first array is my first column. So I'm going to go to the top, highlight all the values in the first column. Then I'll click in the box for the second array. I'll scroll to the top of that second column and then go all the way down to the end of my second value, and I hit OK. This puts in 0.86, we can see that we got earlier. If I wanted to show more values, I can right-click, Format Cells, and on the number, increase the number of decimal places that it's going to show. Here we can do a comparison and see we have the same values. If you want to do R², I would write R². I would say equals. I would click on the previous number and square it. There's your 0.74, which I can again change by hitting Format and increasing the number of decimal places. When you look back, you can see we have the same R² on the chart that we got from using the statistical functions. This time R is 0.8613633. The values are still strong, but not as strong as our first example. R is positive, which we said we expected because when we look from left to right, the values are going up. We also see a positive slope of 0.1871 and our line of best fit. Our R² being 74.19% says that we can attribute 74.19% of the number of views to the length of the video. But one more time, let's say that just because we could find a correlation between the length of the video and the number of views, we can't say that the length of video caused the number of views to go up or down. As you get started on the assignments, remember that you have choices on how to come up with the values of R and R², whether you're using Excel or Desmos to complete your work.